Alright guys, so today we started Unit 3, our new unit, over, if you remember the lesson today, it was Wholey Fractions. Now I know a lot of folks were taking the retest today, so you may not have got all the way in on the lesson, so I wanted to make sure I covered everything that we did today in class on this video. I know it's a little late me getting on, but I had a meeting I had to go to after school, but I do want to cover what we went over, alright? Now, if you have your book at home and you're looking over on page 265, they have the word commutative property, and it's highlighted in your book. And they try to make an example out of a commuter train, and how the commuter train, in case you guys didn't know, it travels the same distance every day, but it goes both ways. All right, meaning that even though it goes different directions, it still travels the same distance. And mathematically, what we're talking about with the commutative properties is a little bit different. So let's say when we're talking about, let's say I have a problem, a math problem, and it's 2 plus 1. Does 2 plus 1, does it equal 1 plus 2? Oh, no, hang on, let me get my color right there. All right. 1 plus 2. Does 2 plus 1 equal 1 plus 2? Well, 2 plus 1 is 3. 1 plus 2 is 3, therefore 3 equals 3. So these, regardless of how I switch my numbers, the operation tells me, all right, as I add both, it tells me that yes, they are both, all right, yes, they are both the same. Now look at my next question. What if I have 2 minus 1 equals 1 minus 2. Now, question is, do I get the same answer? Is this statement true? Does 2 minus 1 equal 1 minus 2? Well, 2 minus 1 is 1. 1 minus 2, wait a second. 1 minus 2, all right, they're not the same, right? So we would say that these two are not the same. All right, so let's move on to, let's get some headier stuff. Let's do multiplication. All right, let's say 2 times 1 equals 1 times 2. Now, is this statement true? Right? 2 times 1 is 2. 1 times 2 is 2. So 2 equals 2. So this statement is true. So yes, this statement is true. Now, how about this? 2 divided by, all right? 2 divided by 1, does that equal 1 divided by 2. So 2 divided by 1 would be 2. 1 divided by 2 would be 1/2. So no, they are not the same. Now, so what can we learn from this? Alright? Now, we've talked about this earlier, and what do we say was the definition of multiplication? Now, I've kind of wore this out with you guys. What was the definition of multiplication? It's repeated addition. So we do have that connection between addition and multiplication. But as you look at them, you will notice that it is addition that equals the same and multiplication that equals the same. Okay? As well as the connection between subtraction and division. So for the commutative property itself states that it's what makes these true. It says as long as we're adding or multiplying, I can switch my numbers and it won't make a difference. All right. Some folks had a problem with this on 4, 5, and 6 of the work, the class work today. So if you haven't done it yet, just know that if you're adding or multiplying, which in this case will be multiplying on the classwork, it doesn't matter which one comes first, the whole number or the fraction. But that is the commutative property in a whole. Now, moving on. Now, at the beginning of the year, I talked to you guys, and you may remember we talked about how to read a division sentence. All right? And it was dividend divided by divisor. Okay? And I said it can also be written another way. Dividend over divisor. Or it can also be dividend, when we actually do the work with the standard algorithm, dividend divided by the divisor. Thus the name divisor. Now you guys remember I said divisor because anchor. It makes me think the divisor is in the bottom. Okay? So today, talking about multiplying whole numbers. All right? Talking about multiplying whole numbers and fractions. Okay? How many of you actually remember how to do that? I'm sure it's an issue. Okay? Many of you probably remember how to do it. Some of you may not. So, let's look into it. Now, to understand how to multiply whole numbers by a fraction, we must remember the multiplicative identity of the number 1 tells us any number times the number 1 equals that number, right? Any number times the number 1 divided by a number. That also goes into effect for division. Any number divided by 1 equals that number, right? Any number divided by 1 equals that number. Had some folks try to say 0 and some other crazy things today. So look at this problem, and I did this problem in class today. So let's say you have 2 divided by 2 over 1, so 2 would be our whole number, okay? And we'll say 2 times, right? Because 2 is my dividend, 1 is my divisor, 2 divided by 1 gives me 2. So 2 over 1 is equal to the whole number 2. All right? Now you were probably told by a teacher that it's just mathematical. Okay? We just turn a whole number into a fraction. Well, the way we do that is going off of the fact that that whole number divided by 1 gives me that number. So I can take 2 and I can make it 2 over 1. Alright, now if I multiply, say I was doing 2 times, let's say, I think I used 1/3 today in class. Alright, 2 times 1/3. Now, I know you guys have grown to me. Oh, Mr. Hearn, fractions are so rough. And I understand that. I really do. A lot of people, when they see fractions, even adults, they will freeze up as soon as they realize that they have to do some type of work with fractions. Guys, fractions are our friends, okay? Don't act like they're the worst thing in the world. They're not, I promise. I do a lot with fractions in my classroom. Okay? So, as I want you to look at this, all right? So, we're talking about 2 times 1/3, or 2 over 1 times 1/3. Okay? So as I multiply is the easy one when it comes to fractions. Addition and subtraction, we have to find that common denominator. But for multiplication, and we'll talk about division later when we get there. Alright, for multiplication, it's simple. Numerator times numerator, denominator times denominator, or dividend times dividend, divisor times divisor. And I know that's a little bit of out of subject talk, but I'm simply going to go, all right, for my answer, okay, for my answer, I'm simply going to go 2 times 1 is 2, all right, and 1 times 3 is 3. So my answer for 2 times 1/3 is 2/3. Now, going back to the repeated addition part, okay, think about the repeated addition that we talked about. Multiplication is repeated addition, so I'm actually adding 1/3 two times, so 2/3. But there's other ways to look at this. Now, I did this today. We talked about the area model, okay? So it's 2 times 1/3. So I'm going to draw 2, all right, 2 holes. And I'm going to divide it into thirds, okay? So this is the area model. So this represents this. Hang on, my marker. This represents the 2, all right? And I'm going to fill in 1/3, 1/3, right? So this represents the 1/3 in our problem. So now I have 2 times 1/3. Okay, now the tricky part about the area model of multiplication is understanding how it works out at the end. What are we looking for? We're looking 2 times 1/3. We're looking for thirds, all right? So I'm going to set up, just like I did here, my holes, all right? And then I'm going to count my thirds. So I've got 1, 2. So how many would I fill in here? I'd fill in this many. 1, 2. And that is 2/3, which gives me my answer of 2/3. Okay, and that's the area model of multiplication. Now, I know some of you today looked at me like I had a third eyeball when I covered this in class. Don't worry about it. But what we're actually doing here, guys, all right, we're bringing them over, but the key is to remember that I'm trying to figure out how many thirds there are, right? That's an easier method if you don't have to do the multiplication across. Now, some of the larger ones that we have on the homework and things like that, it won't be that way. Obviously, there will be some differences to that. Like, you're not going to want to write out 20 of these things, okay? We're going to be a lot simpler just to use our standard algorithm and come across. 2 times 1 is 2, 1 times 3 is 3, okay? Now, for the most part, that's how we're going to do it. Now, I told everybody today, if you get a mixed number for an answer, and let's talk about what mixed numbers are. Some of you were drawing a blank on that today. Remember, a mixed number, okay? A mixed number is when I have a whole number and a fraction, okay? We're going to go over how to handle those later. But what you're going to be getting, what we're doing today, this is a mixed number. What you're going to be getting on your homework today is what we call improper fractions, okay? And improper fractions occur, all right? Improper fractions, I should have did a different color. Improper fractions occur when I have a larger numerator over a smaller, right, denominator. Okay, so that would be an improper fraction, 32 over 3. And if you remember how to do those, that's great. I told all you guys that in class today. If you remember how to solve those and break them down, that's fine. But I also said I will take an improper fraction for today. And we'll talk about later how I want you guys to simplify those and knock them down. But if you can see the simplify, I think if you look at number 1, I think you'll see the answer should pop right in your head and what's going on with there. I know number 8 is going to be tricky. I've already had a bunch of questions on number 8. So we'll cover it tomorrow in class. I know for sure number 8 we'll be working on. But that's the lesson for today, guys. That's Wholey Fractions. That's getting us started on this whole new unit. All right? And we're doing nothing but multiplying and dividing fractions. So sit back, hang on, and we're going to have a good ride.